In this video, I'm going to go over another form of a proof that's different than the informal or paragraph form. Before we go into that though, let's go over a couple properties that we went over in algebra for all real numbers. First, the reflexive property. And the reflexive property states that for every number a equals a. So if I was to say that a equaled 6, well then we know that 6 equals 6, and this is an example. The next property is going to be the symmetric property. And this states that for all numbers a and b, if a equals b, then b equals a. So, for example, if I were to say that a equaled 2 and b also equaled 2, a and b, 2 equals 2, and 2 equals 2. Next, we're going to go over the transitive property. And the transitive property states that for all numbers a, b, and c, if a equals b and b equals c, then a equals c. And let's show that through example. So let's say that a equals 1, b equals 1, and c equals 1. If we have that 1 equals 1, because a equals b, and 1 equals 1 again, then we have that 1, a, equals c, which is also 1. Let's continue on with even more properties of equalities. So the addition and subtraction property says that for numbers a, b, and c, if a is equal to b, then a plus c equals b plus c, and a minus c equals b minus c. Let's show an example of that. So a equals 2, and a equals b, so b also has to equal 2, and c can be whatever it wants. So let's say that c is 1. So a plus c, 2. So 2 plus 1 equals, b is 2, c is 1. 2 plus 1 equals 2 plus 1, which is 3 equals 3. And then we have 2 minus 1, a minus c, equals 2 minus 1, which is just 1 equals 1. Now we're going to go over the multiplication and division properties. So the multiplication and division properties is very similar to the addition and subtraction properties. It says that for all numbers a, b, and c, if a is equal to b, then a times c equals b times c, and remember c cannot be equal to 0 in the denominator, so and as long as c is not equal to 0, a divided by c equals b divided by c. So an example of this, we can say that a equals 4 and a equals b, so b also is equal to 4, and let's do c is equal to 2. So a times c would be 4 times 2, b times c is also 4 times 2, so 8 is equal to 8. Then we have a divided by c, so 4 divided by 2 equals b divided by c. Another 4 divided by 2. 2 equals 2. So this is just the addition and subtraction, multiplication, and division properties. Let's go over 2 more properties of equality for real numbers. So the substitution property states that for all numbers a and b, if a equals b, then that a may be replaced by b in any equation or expression. So an example of this would be if I said that a was equal to 3 and b was also equal to 3. And I said figure out what a plus 6 minus 4 is. Well, instead of substituting in a, let's go ahead and use b, because we know that a and b are equal, so b plus 6 minus 4, and see what that equals. So 3 plus 6 minus 4 is going to be 9 minus 4, which is equal to 5. So a and b are easily replaced by b or a. So as long as one variable is equivalent to the other, they are interchangeable. And the distributive property says that for all numbers a, b, and c, a times b plus c is equal to ab plus ac. So an example of this, a equals 2, b equals 3, and c equals 1. So a, 2 times 3 plus 1, and we need the c, that's equal to 2 times 3 plus 2 times 1. 2 times 3 plus 1 is 4. Is that equal to 6 plus 2? 2 times 3 plus 2 times 1. 8 is equal to 8. And that is what the distributive property is saying. So in a two-column or formal proof, each step is a statement, and those statements are organized into two columns. It would look something like this. So you have your statements on one side, and you have your reasoning or reasons on the other. So statements, you can list your reason for one of them could be that it's given. List something again. Like in our previous video where we used the segment addition postulate, we could write that out and then write segment addition postulate. And so on. So let's go over an example of a two-column or formal proof, and we're going to use those properties of equality that we just went over. So we have to prove if 4 times x plus 2 equals 16, then x equals 2. So let's go through our steps. Understand what it's saying. So we need to show that x is equal to 2. So we need to show that that variable is equal to that numeric value. List what's given. We're given that 4 times x plus 2 equals 16. We can't really illustrate that, so we're going to skip that step. And now we have to list what we need to prove. And that's that x is equal to 2. And now we're going to develop the steps. But in this case, we're going to do it in two columns. So it's our two-column proof, or our formal proof. So we're going to have statements in one column, and reason in the other column. So, our first statement, we're just going to write down what's given. So 1. 4 times x plus 2 equals 16. And that's given to us. Now let's use the distributive property and distribute this. So distributing the 4, we get that 4x plus 4 times 2 equals 16. And that's where we use the distributive property. Because we're taking this 4 and multiplying by the 2, and taking the 4 and multiplying by the x, and adding those together. And our next step, we're going to simplify this or use substitution. So we have 4x plus, and we're going to simplify this part right here. 4 times 2 is the same thing as 8. So the number 8, because that's what 4 times 2 is equal to, and then equals 16. So this step is substitution, and I like to also call that simplify. And that's taking two numeric values or more and rewriting them as a single one through addition, subtraction, multiplication, or division. Now, if we have 4x plus 8 equals 16, our next step is to get rid of that 8. So we're going to do 4x plus 8 minus 8 equals 16 minus 8. And that's saying that since 4x plus 8 is equal to 16, I am adding or subtracting that c. So this is going to be the subtraction property. And again, we're going to substitute or simplify. So this is going to be 4x. 8 minus 8 is 0. And anything plus 0 is what we originally had. So 4x. And 16 minus 8 is 8. So again, this was substitution or simplify. Step 6, we need this x by itself, so we're going to use the division property and divide by 4. So we're going to have 4x divided by 4 equals 8 divided by 4. And that was the division property. And last but not least, step 7 is finishing this out. 4 divided by 4 we know is 1, and anything 1 times x would be just x. And 8 divided by 4 is 2. So we get that x equals 2, which was the statement we needed to prove, and that was because in our last, again, we substituted or simplified. So you can see our 2-column formal proof led us to prove that x was equal to 2, given that 4 times x plus 2 equals 16.